Hi everyone, welcome back to Java 1 for All. In this video, we are going to talk about concurrency. We have been working with threads, but the way we are working so far is basically the low level. We are basically working with the threads in the most raw way possible in Java. The package we are going to work now, the concurrent package, was a package added to work as kind of an abstraction layer. So imagine that we are going one level up and things get a little bit easier every time you go up. So let's create a new package here and let's talk about the first part, that's atomic variables. Let's create a new package, zz, I think vrg, concurrent.test, and then create a Java class. Let's call it AtomicInteger test01. So let's start with a problem, a very simple problem. Imagine that, for example, you are creating a game. In this game, you have monsters that are spawning in a map. Imagine that you have two threads that are handling the monster counter. One thread that's basically responsible for spawning the monsters, and another thread that's the player thread that's killing. So basically, you have one adding and one subtracting the monsters. Basically, you have two threads accessing at the same time the same value. That's the counter of monsters. So let's see, for example, what happens when you do something like this. Let's create a class called counter, and this counter will have only one attribute called count. I will create the getter, and then I will create a method. There is no need to be public because we are going to use only inside the atomic integer test. And one to increment. So basically, every time I call this method, we will have one added to this count. Cool. Let's come here now and create here a counter, new counter, and then let's create a runnable, and this runnable will have a for I from 0 to 10,000, and then I will just call counter.increment. Cool. Now let's imagine that we have two threads. We have thread 1 that we are passing this runnable. Create here T1, and then you have thread 2. And then I will tell, hey, thread 1 just start, and then thread 2 also start. But I do want to get, for example, the counter.getCount. Remember, the main thread will just finish this even before the threads they finish. So let's do the following. Let's tell main thread to join T1 and T2. So T1.join and also T2.join. Let's add an exception to the method signature. And before we run this, even though the concurrent package that we are going to work with, it's adding a kind of a layer of abstraction over the raw threads, it's still important for you to understand the lock, synchronized code, or wait, notify all, and all the concepts that are related to threads. Because if you don't understand that, the layer of abstraction, it may make things a little bit more complicated than it should. So Ctrl-Shift-F10, and as you can see, when we have two threads accessing the same counter, we have a huge problem. So for example, we were supposed to have like 20,000 because we have two threads running from 0 to 10,000. So as you can see, every time we run, we have different values. Even though you look at this count as one line, maybe behind the scenes, this is more than one line. We don't know what happens when Java compiles this code and sends to the processor. So usually processor, when they are doing this counter, they kind of have like a temporary variable where they store the value. So if you have multiple threads accessing, the values can get lost in between. One solution here would be to add synchronized, and then this code would work. But again, when you add synchronized, you are kind of locking this entire object and you have some kind of a hit in the performance. What we want here is that the counter should be incremented in an atomic way. Basically, always do things that will not compromise the current value. And we have one class that's basically doing that for us without us having to synchronize and lock everything. That's called AtomicInteger. So AtomicInteger is a class that will work with integer, that behind the scenes they are using the concept from computer science called compare and swap. So basically the compare and swap is a technique that we use when we are designing concurrent algorithm that compares and swap the expected value to the concrete value of the variable. So if the concrete value of the variable is equals to the expected value, then swaps the value of the variable for the new variable. So it's a little bit more complex because this go way beyond what we are trying to explain here. But for the purpose of this course, what you have to understand is that when you have atomic integer, the operation of adding one will be atomic. So you don't have to worry about locking the entire method, the entire object. So let's do this. We have a couple options here. We have increment and get and increment. As the name says, you first get and then you increment one, and you can first increment and then get the value. So let's increment and get. In the end, we are not going to get this back. This is going to return integer, but we are not going to use. But we are going to add here another getter, that is get atomic integer. Okay, so now all the way here to the end, I will add get atomic integer. So let's see the result. Control Shift F10, and we have the value 20,000. So even though I'm not locking, there is no synchronized here anymore, we still get the value that we are looking for. If we have two threads running the for loop 10,000 times, we should get 20,000 for the same object. So this is just one tiny example about the atomic integer. You do have different options. You have atomic integer, boolean, integer array, long array, and so on. So basically, the concurrent package is adding a little bit more methods that we already have. This everything that we have inside of the concurrent package. We could technically do it manually, but again, Java is always trying to make things easier for you as developers. So you have like a whole team of developers that are thinking about this kind of problem. So why not just use whatever we have out of the box? So in the next video, let's talk a little bit more about the concurrent package, and let's see how we can work with the lock without having to synchronize the object. So I see you in the next video. Bye.